instrumentation technician, test conductor, mechanic, telemeter engineer, Army proof officer, radar technician, command control engineer. What you are seeing is the operation of launching a guided missile of the Convair MX-774 type. We are now going to move time backward and show you the firing range, ground installations, and trained men necessary to launch the MX-774. This is the ground layout of the White Sands Proving Ground, located near Las Cruces, New Mexico. From the blockhouse, the telemetering station is located 1 mile west. The radar station is 3 miles south. The launcher is 500 feet north, and command control is located inside the blockhouse. The ground receiving station for the MX-774 telemeter is contained in a truck, which is placed in the most desirable location for the firing. This location was chosen because it is in a direct line of sight to the launcher, assuring good radio frequency signals while the MX-774 is on the ground. The ground radar installation consists of 2 S-band and 2 X-band units, with 2 automatic plotting boards, which together give a record of the missile trajectory and velocity while in flight. Headquarters for the chute is the white concrete blockhouse 500 feet south of the launching table. Its interior includes the firing panel, pulse timing system, command control unit, and stations for operating personnel. The MX-774 is being towed from the shop to the launching site, where it will be prepared for flight. The launching table to trailer hinge pins are installed and the stabilizer jacks adjusted. One man can raise the missile into position to set it on the launching table. The missile is guided into place by a man on each fin. The missile is secured, the trailer lowered and moved away. After installing the missile on the launcher, a preliminary vertical alignment is made. Convair technicians adjust the alignment jacks on the table. The Army engineer signals the alignment is satisfactory. The radar beacon, being installed in the missile, receives impulses from the ground radar transmitter and then sends out answering signals, which enable the ground station to track at greater distances than is possible without the beacon. During flight of the missile, the radar operator keeps continuous watch over the return pip from the beacon, adjusts his circuits for the changing range, and makes corrections for frequency drift or other minor changes which might occur. All information received from the radar tracking systems is fed into the plotting boards where azimuth angle, elevation angle, and range to the missile are converted to trajectory data. One plotting board presents east-west deflection versus elevation. The other shows north-south position versus elevation. To facilitate control of the missile, lines are drawn on the plotting boards indicating the various control zones. With the help of these plots, the flight director can see at a glance what control commands, if any, are necessary. In addition to trajectory plots, the data received are converted into velocity, vertical, north-south, and east-west, and then plotted on moving tapes, giving an instantaneous record of the missile speed. Peak is determined by vertical velocity becoming 0. After the selection of a suitable location for the telemeter ground station, the two double turnstile type antennas are erected, the power unit connected, and the equipment prepared for operational testing. Inside the truck are located two frequency modulation receivers, two filter and discriminator units, two 14-channel recording oscillographs, and other equipment needed for adjustment and checking of the telemetering system. All sensitivity controls are adjusted for proper settings. Recorders are tested for operation. Just prior to firing, a final tuning of the receiver and a final signal strength check are made to assure satisfactory operation of all equipment. The command control transmitting antenna, located outside the blockhouse, is given a final physical check and is adjusted for proper direction and angle. A 3-channel control system is provided in the MX774. 2 channels are used to provide guidance in pitch and yaw, and the 3rd channel to trigger fuel cutoff, parachute release, and missile destructor. The controls for pitch and yaw are checked through their operating ranges, which are 2 degrees south, 8 degrees north, 4 degrees left, and 4 degrees right. The safety sequence check is now in process. Fuel cutoff, parachute release, destruct. A stabilization amplifier has been rechecked and is ready to have the cover sealed in place. After the cover is on, the engineer installs the amplifier. The stabilization test panel is connected to the missile and calibrated signals are applied. Response of the system is observed on the test panel meters. Known signals are applied through the panel and system response is recorded by telemetering. The calibration is then used for analysis of missile flight records. The rocket igniters, yellow in color, are installed in the 4 rocket cylinders. The yellow case being installed contains the photo recorder camera and recovery radio transmitter. The black object on the side of the case is a gun camera to photograph parachute ejection and descent. Primer cord for warhead ejection is installed. Photo recorder cable is attached to the parachute harness. The instrumentation engineer makes his final inspection of the recorder installation. The recovery parachute packed at Holloman Air Base is inspected for proper installation by the Air Force project officer. Installation is satisfactory and warhead is lowered into position and secured. The camera used to photograph the Earth during flight is installed on the side door. This mobile pump is used both for stabilization hydraulic system checks and to fuel the missile with alcohol. The line goes up the missile and into the alcohol tank, which is now being fueled. The hydrogen peroxide fill tank is hoisted into position. The 2 men fueling the missile with hydrogen peroxide are wearing protective clothing. Severe burns can be acquired from the concentrated hydrogen peroxide if it comes in contact with the body. The truck is maneuvering into position to fuel the missile with liquid oxygen. The fill valve is screwed into the tank fitting, and the line is connected to it. All connections are complete. The fill valve is opened, and liquid oxygen is being pumped into the missile tank. With the fueling completed, final vertical alignment of the missile is made. The test conductor notifies the blockhouse and all range stations that work is progressing satisfactorily and on schedule. In order that work will be accomplished in proper sequence and that no item be overlooked, checklists for all are prepared before each shoot. During operations, test engineers check off each item as it is accomplished. Command control is ready. Radar ready. The telemeter engineer completes his signal check and is ready to record. All range stations are ready. Stand by for the pre-shoot countdown. The voices you will hear from launching through impact are from an actual recording made during the shoot.
X-minus 1 minute. Roger West. Roger C. Roger South. Roger Command Control. 45 seconds. $20, $90, $80, $60, $50, $40, $30, $12, $11, $10, $9, $8, $7, $6, $5, $4, $3, $2, $1. A, B, C. Take off. 5, 10, 15, 20, 25. Very good from the west at 25. Roger. 30. Very good from the south at 25. Roger. 35. Roger. 40. Command control, modulation on. 45. Roger. Very good at 45. Very good. Torque the heat. Are you getting programmed? Command control, 7 degrees north. Just started. 55. 60. Keep counting, blockhouse, will you? 65. 70. 70. Give me burnout. 75. 80. Beginning to bend over. Command control. 85. Cut off. 90. Command control, fuel cut off. 95. 100. 105. 110. 115. 120. 125. 130. Command control. 135. Release. Command control, parachute release. Puff and smoke occurred. Parachute is on the nose. Parachute broken loose from the rocket. This is the West Station, Herb. I see a object falling. Wait. Roger. That might land close to the blockhouse the way it looks from here. In control. Destruct. Command control, destruct. We're getting near the impact. Impact! Impact! Hello, blockhouse. Blockhouse. This is Radar C. The range to the impact from Radar C is 10,520 yards. 10,520 yards from C station. Roger, at 490. 490. Repeat, 490 mils. Mils. Roger. Roger. Command control to Station C. Major Calhoun would like to know if the maximum altitude has been determined. The maximum altitude is approximately 30 miles, Command control. This is Radar C. Roger. The velocity from the brush recorder's blockhouse is 2,240 foot-seconds. 2240 foot-seconds. That's max velocity. Max, right? Well, this is Radar C, over and out. Well, this is the blockhouse, over and out. Roger.
This flight of the MX-774 concludes a firing program of 3 missiles, which, in addition to supplying technical information, was invaluable in the training of personnel. A striking indication of the effectiveness of training is reflected in the time spent at the flight base prior to the shoot. 35 working days were required for the first missile, 12 for the second, and only 7 for the third. It is felt that even this time could be substantially lowered with added experience. Even with the large number of items requiring accurate adjustments, not a single malfunction in all 3 flights can be traced to human error on the part of operating personnel. In particular, the operation of the intricate and sensitive stabilization servo system was flawless, making all 3 flights outstandingly successful from the stabilization standpoint. Therefore, Convair is proud of this achievement in the guided missile field.